All right. My hello to everyone. My presentation is on improving Gradle bills, and I'm going to present to you on how to benchmark them, measure them, what tools you use to optimize them. So, you may work on a large code base where, where the code base is broken apart into different modules. And there are benefits, by the way, to break it apart into different modules. And one of them is code sharing, for example. So when you're working on a large code base, and you're tasked to improve the Gradle builds, improve the build times, how do you go about benchmarking it, measuring, and getting data? So the great thing about like working on Gradle builds is that there's a lot of metrics that you could get. So there are metrics that you could work towards and set as goals. So let's look at how to do that. How do you measure and get metrics in a large code base? And so for this presentation, I'm going to share with you this open source repo by Uber, which is basically a repo called Uber Bill Eval, and it's a repo that basically is a replica of the Uber production app, and it's a replica in terms of the module structure, and it has about 1,292 modules and has a lot of relationships between those modules. So this is open source project that you could use to play around with Gradle builds to improve build speeds, etc. So when you look at this project, how do you go about collecting data? So, how do we analyze our bills? Basically, that's the question. And there are multiple ways to do it. So Android Studio itself has a build analyzer. So when you run your application, it will show you and give suggestions on where the bottlenecks are, like how long it took, and it gives you a really nice visual. But what if you wanted to basically you had multiple teams that were, you had a large team, right? And you wanted to look at not just your bills, but also your all these different teams and be able to collect this data, bill data, in a central store. And you want to be able to look over time, how the bills are being approved, so that you could set goals to hit certain baselines. So how do you collect that? How do you do that? How do you analyze it, in a large team? What tools could you use? One of them is a tool that I use is called Gradle Enterprise. And it's a tool that does exactly that, what I just told you. You could set it up where you could look at the bills, all of the bills and all their metrics over time, basically 90 days, 60 days, etc. You could look at different statistics like speed and how good the configuration time is. So this is a tool which is you could there's a free trial that it has. It's a tool that you have to get a license for, and it's a really, really great tool that I recommend. So suppose for this application, I wanted to run a create a bill scan, basically, that allows me to look at it in Gradle Enterprise. And there's a way to do that for free. You could pen, for example, I'm doing here dash scan, and you have a root module, and then you have basically a symbol debug. So what I'm doing here is that I'm doing a clean build of this large repo, this large project, basically. And let's look at what happened and what the data is and how the data is represented in Gradle Enterprise. So when you go about creating your bill scan, it will, you'll get a URL that you can navigate to. You also have the ability to delete your build. So you also have the ability to delete this bill scan if you don't want it. So this is what you see when you basically create a bill scan. And over here, you could now navigate into different types of information to optimize your bill scans. You need to look at the data first, right? Where the problem is. So this is a large project where it took about 11 minutes to build, and that's understandable because it was what they it was on a clean like Gradle cache. So when you look at what information does this give you? So performance gives you information such as the configuration time, the build time, and it gives you information on like how long is it taking to get dependencies, for example. So this is the information that you could dig down into and to identify what the problems are, what the bottlenecks are. So this project took about 11 minutes to build, but when it took 11 minutes, was the time spent in configuration or was it spent in task execution? So execution time, initialization was really, really fast. It took about 36 seconds. But the execution time, as you can see, was 10 minutes when you look at this. So you could also go down and now get more information on what was being configured, and in what order and what was the duration of each plugin configuration time. So this is another more information that you could look at in Gradle Enterprise, which shows you all of the plugins. So there's the Kotlin Android plugin and all the different plugins that are being configured. And you could sort it in order. And what you want to look into here is that which one is taking the most duration here, and dig down into why. And you can also look at it and you could order and dig deeper into which modules basically where it's taking a lot of time. You can see there it takes about 8 seconds to configure in the module on 857, for example. So the other part, besides configuration, is to look at a timeline of all the tasks that were executed and how long did they take. So this is what task execution, the information that it gives you. So when you look at this, you could see that how many tasks did it get from the cache? What were the cache hits? How many percent, what percentage? And then you could look at basically how many tasks were non-cacheable. There were 59 tasks that were specified as non-cacheable, whereas the other ones were. So this is keep in mind on a clean build. So when you look at the timeline, you go into the build timeline, and then it will show you all the tasks that were executed. And over here, you want to look at basically, so the ones that will be from the cache, well, you could see it says from cache. And you'll see in here, you could drill down into what the hash code was for the cache, and what the input was that actually made it, miss the cache and update it. You could organize this by duration here. So this is really useful data to look at as you're basically optimizing your builds. So one of the other things that you could do is that when you work on improving your build times, you may want to differentiate the tasks by you could work on improving local build times versus CI build times. So one of the things that allows you to differentiate the data in Gradle Enterprise is using build tags. So in Gradle Enterprise, you have the ability to look at all the bill scans. These are all the bill scans like in a team, and you could look at all of them. But you suppose you wanted to filter by bill scans that were for local bills, not on CI. And you could do that. You could specify a tag to do that, and that's really useful to drill down into the specific data. So how do we integrate this tag feature? So the way you integrate Gradle Enterprise is that there's a plugin that's provided to you. So you specify the plugin in your project. And then what you could do is that you could configure it to basically set up your build scans. So when someone like does a build or install of the app, you'll see that you could specify that if it's a CI, then set a tag of CI or set another tag for local, and then send it up when the build scan is being uploaded to Gradle Enterprise. So this is really useful because you want to work on basically either local builds or CI builds, whichever one whichever one is a priority for you to improve. So when you could use that tag and then configure it over here. So far we looked at how to be able to get data, across different teams, and how to get build data basically. Now let's look at how to do optimization. So there's a two-step approach that you could take. There are small optimizations that you could do up front, but then at some point you have to think about modularization, how your application, how your build graph, your Gradle modules are basically structured. Are they structured? Excuse me. Are they structured in an efficient way or not? So let's look at some small optimizations that you could make, when you as you start out to on this journey of improving your build times. And they have to do with these three different things. There are tools that are available that are open source that will help you to improve your configuration time, your dependencies, downloading time, etc. And one of the good things to do is to turn off like Android Gradle plugin features that you don't really need. And what you'll see when you go into Gradle Enterprise is that when you turn them off, you'll see, even though it will be a small gain, it will, when it multiplies, it really has a big factor. So when you look at here in Gradle module in this configuration data, you'll see the Android Gradle plugin there. And how do we turn off certain features? What features could we turn off? You could turn off the render script feature. Um, you could specify this in your Gradle properties file. So you would turn off. You could also turn off this feature of generating shaders, for example. And so there are also other types of features like generating build info, for example, that you could turn off. You could also turn off, data binding or v binding, etc. So turning off these features where they're not needed in modules is really, it's important. It has an impact. The other one is that when you look at, like, if you're improving build times and you're working on a legacy code base, right? And it has, suppose it has like 100 or more modules, and you probably, if you don't have like some way to auto generate module, like a script or something, people are probably copying existing modules, and they may forget to remove unneeded like plugins, dependencies. And so how do you account for that? How do you optimize that? So there's a plugin by Tony and from Square. He has a really great plugin, and he does a lot of great things in this area, improving build time, improving your Gradles builds. And one of the plugins that he has is called Dependency Analysis plugin that I really recommend you to use. And what it does is that it could analyze your Gradle project, and it could tell you module by module, like what are like plugins or dependencies, module to module dependencies that are not needed. It could also provide you with like suggestions on API versus implementation, and it analyzes the ABI basically of your project to determine these things. So the way this is a module that you specify like this in your root, you specify in your root project, your root Gradle script, your root module. And it has basically a task. It has two tasks. One is called project health, and one is called build health. And when you run project health, it will output a report. And this is what the report kind of looks like. And it basically like shows you project module by module, like what are some unused dependencies. And it also shows you may be specifying like a capped dependency, like a capped in a module, but you're not basically using any annotation processors. So that also has an impact and on your build time. So it will give you advice that these things are not being used, they could be removed. And what you want to do basically is that you want to set up this tool on Circle on either Jenkins or Circle CI that you could run regularly, like nightly maybe or weekly, that gives you this report and it's able to like help you to build like lean Gradle modules, and it has an improvement on your build times. So one another thing that will help you with like your build cache, basically any issues with them to optimize build cache is that, so the way a build cache works is that like when a task is executed, it has a set of inputs. And when they take those inputs and produces some result, and the result is like stored in a cache, and depending on, it takes into account the inputs that were given to it and generates a hash, and it stores the result, the output in the cache. So the next time when you run the build and you go about executing when it goes to execute the task again, it goes and takes the inputs and then determines if it's in the cache, and it will get the result from it. This is really, really helpful for you to improve your build times, build caching. So there is a plugin that, someone named Nelson Osaki, he works at Gradle. He has this really great tool called Gradle Doctor plugin that's really, really useful. And what it does is that it identifies tasks that are slow, that are basically slow from the cache. They don't provide a lot of usefulness for caching them. And it provides you with a lot of Gradle build scan tags that you could use and go into Gradle Enterprise and look at for optimizations. So wait, this is how you would specify it in your root, application. And then what you would do is that you could go into this tags and you could filter basically build scans over time. And you could filter it by these tags. Negative savings, like which you could look at, you'll be able to filter like which build scans have negative savings, like which build basically have which bills that were run on your team, like where you got the negative savings, where it took a long, like basically to unpack from the cache. So you could also tell you like slow build cache connection, for example. So how do you go when this tool will tell you which tasks are not really useful for caching? How do you disable like caching for a task? And you could do this. This is for local caching. You could do task names and outputs cache if to false. So you could also like disable remote caching like this also. So the other thing that this plugin does is that when you're using Dagger, obviously, that could take a long time, depending on how, you have set up your graph, the dependency graph. And you could set up a threshold basically on how long it takes, and if it takes longer, for example, than this threshold here, it will give you a warning. So this is good for like optimizing Dagger. It's also a feature that this plugin provides. So lastly, there's another plugin library by Nelson Osaki from Gradle, is that it's called the Android Build Cache plugin, and I highly recommend for you to add this, where basically it has workarounds for room, for example, and it fixes common like build problem like that AGP and Android Gradle plugin like has. So this is something that I recommend for you to add. So we looked at these three different tools. Adding these three different tools goes a long way. These are good things to do as you're starting out to improve your build times, improve your builds. So the next step when you have done this is to look at how you have set up, your Gradle modules in your project. And what are the tools that help you to enforce good practices? And what are some tools that are going to help you to determine like how good or bad your module graph is? How could you visualize it also? So suppose like you have a module like this set up. This is a very simple module setup. And how do we enforce like best practices and with modularization? So my recommendation is that you don't want people to copy when they go to create new modules. It's good to have a script that auto generates new modules with the dependencies that they want. So that's something that's useful to do to prevent people from copying existing modules and modifying them. So one of the plugins that's in the community and it's open source called Modular Graph Assert plugin. What it has the ability to do is to enforce conventions. It has the ability to visualize graphs. You have the ability to check the depth of a graph and how what is the longest path that you have in your module structure, and then you can move forward with this information to optimize it. So I would add this in your root, basically your root Gradle, project, your root Gradle module, and you could configure it. So one of the configurations that you could have is that you could configure the max height in your basically your build graph, and the max height is the longest path from the root, basically to a leaf node in your module. So this is the max size and number of edges on the longest path from the node to a leaf. That's what it is. And if you had, for example, like a max height of 4, you could specify, for example, max, like this example in here, there's a max height of 4. Like on the left, you can see to that leaf node, it has like 4 edges connecting from it. If you had a max height of like a really long, that's really bad for your Gradle builds. So what you could do, the way if you were to configure this, and the way you could check at build time, for example, uh, you could check as part of your build process. You could run this command, and it will check whether your module structure adheres to the rules that you specified. So, for example, if you set a max height of 3, it will give you basically an error when it goes to determine your longest path. So you want to set optimal numbers depending on your project for that. So you could also set like, one of the things that's really useful is that you don't want in your setup certain modules to depend on others. For example, like, so here you could set up like your app module to depend on, you should only depend on like feature modules, and your feature modules should depend on certain libraries. So this is a convention that I'm setting, that I'm enforcing here. And you could also restrict that certain modules, for example, shouldn't depend on like some forbidden module that you don't want. Could be a sample application, for example. So this is just really helpful to setting up to enforcing like really good paradigm, good patterns. And the next thing is that when you go about like optimizing and looking at your modules, all your module, how do you visualize it? And there are 2 different tools you could use. This plugin itself has the ability to give you a graph, like a visual graph of it. You could generate a graph of all your modules, but something that's really helpful is to start from a subgraph and then work upwards. So there's a tool that you could download on with Brew, for example, on Mac called GraphWiz, where you give it a configuration file, and then it will basically generate a ping on your graph. So this is the tool that you could use. For example, this is the command, and this command for when you run it for your project, you want to look at all your modules visually, it will generate a file, and then you could take that file and give it to GraphWiz. So this is a type of configuration file for your module graph that it does. So you can see there's a relationship between the parent and the child module, for example. So this is a directed graph. This is what digraph is called. And you could then this would be a full graph. So you could give this to GraphWiz and you could generate a ping. You could also color code this if you have like a Kotlin multi-platform project and you want to color code it by common or iOS module, iOS main, or so if you could also run this on a KMM project and color code different types of modules based on platform. So you could also like something that's really useful, generating a visual of a subgraph, for example. So you could specify which feature module that you want to visualize, which feature, or it could be some library, for example, that you want to generate a graph of. So the next thing that you could do is that you could also generate stats on get stats on your all your modules. And when you run this command, it shows you like the number of modules you have, the relationships in between those modules, and the longest path that you have. And it's really quick. So I ran this on the on the Uber Android Eval project, and I was able to get statistical information from it. So next thing I want to talk about is that how do you set up dependencies like in when you like in a large like modularized application. And some people they add, one approach is that you could add versions file in your build source. But is there a way to do that using Gradle itself? And there's a incubating preview feature that's really nice. I recommend. It's called version catalogs. And what it allows you to do is define all your dependencies in your TOML file. And basically you could share, and one of the great features of it is that you could constrain dependency versions. And that's really a nice feature that it has. That's useful for me. And so the way it works is that you specify a TOML file. It's an extension which it's called TOML extension, and you can specify the versions in that file. It's kind of like a YAML file. You can specify the libraries that you want, but you could also specify, and this is how you would use it. You would generate a libs variable, and you could do androidx.core.ktx. What's really good about this is it allows you to bundle dependencies together, like compose dependencies. Rather than specifying each one of these, I could just do this, and it will include all of them, libs.bundles.compose. In order to use this, because it's a preview feature, you have to specify this in your settings.gradle file. So I haven't had any issues like in the large projects with this, and it has run really, really well. Dependabot does not have support for version catalogs, but there's another bot called Renovate bot does have support for it. So in summary, we looked at these two things that are really useful when you're thinking about modularization and how to optimize things and set things better. Last thing I want to talk about is how do you benchmark things? And this is the really big piece of optimizations. Someone made a change, you made a change in the build script. How do you determine whether regressions occurred or not? So there is a tool by Gradle called Gradle Profiler that I really, really enjoy using, and has helped me a lot, which automates benchmarking, allows me to detect regressions. It allows me to determine experiment, like if certain change was going to improve the build or not. And I'll show you that with a use case. So suppose you had a module like this, and you made a change on the build script, like in a certain module in this graph. How do we find regressions? So there are two steps with this profile, with this tool. One is to write a performance scenario. The second is specify how many number of iterations that performance scenario is going to run. So the profiler runs several builds one after the other, and it tells you and it gives you stats on how long the builds took based on this performance scenario. So the way you can install it locally, this Gradle Profiler using Brew, and then you specify in your assemble command that I want to run this task, assemble. It could be something else if you want. And I'm going to run a benchmark. So I'm going to do benchmark. I'm going to say I want to run a number of iterations. So there's a difference between profiling and benchmarking. And it's 1 for profiling and 10 iterations for benchmarking. And how many warm-ups do you want to do? So before it runs those iterations, it could warm up the Gradle daemon, and before doing those. And these are the numbers you use depending on if you want to do benchmarking or profiling. So when that runs, it takes a while. It generates a graph like this, where the x-axis is the number of is the build number that ran, and the iteration number, and the y-axis is in milliseconds the number how long it took. So you could use this data. It also gives you this data like the mean, the median, the mode, and the standard deviation. And this is really helpful. And you could compare before and after, this data, whether it was good or bad, depending on the change you made. So how do we test incremental builds? For example, you made a change in some basically a build script, and you wanna when the way you do it is that there's something called an ABI. ABI is basically is not just the classes and your files that you have specified. It also a combination of your dependencies that you specified in a module. So in each iteration, you could perform an ABI chain and collect the result. And the way you do that with Gradle Profiler is you do incremental build. And I'm saying here in each iteration, apply an ABI chain to a specific file in a module. And then I could also specify I want to apply changes to resources also. I could test that also. And it will run this task and apply those changes in each iteration. So this is how you would run this incremental build performance scenario, and you would get the results, and you could do a before and after comparison. What about Gradle syncs? And I want to test them. Sometimes, like a change happens, and the Gradle sync takes a long time. That has happened to me. And you could also like specify the memory that you want, and you can specify other things in here and test Gradle syncs. So these are the two steps you would follow: write a performance scenario and then run that command with a number of iterations. So how do you automate profiling on CI? That's the big plus. You could create a pipeline on CI that basically runs nightly and collects metrics over time, and you would set up monitoring for it. What I would recommend is to set up a Docker image that you could pull that has Gradle Profiler, because you don't want to install it every time. And then you could basically write your performance scenarios to the in your application, in your repo that you want to run. That Uber project that I showed you, it has performance scenarios in there that you could that basically that you could run. Those standard basically performance scenarios that it has. And then you want to run it nightly and collect the results and look at the progress. Look at if there were any regressions introduced. So let me give you one use case. One use case, which is using Anvil. Using Anvil is a library by Square, really great library. You could use that has a lot of features on using components. You could also use it to improve your build times. It's a compiler plugin. It's a compiler plugin, and it has the ability to generate factories. It has the ability, you could use it just to do that, to improve your build times. And how do you do that? And how do you benchmark it with Gradle Profiler? The way you do it is that suppose you had a module that was using Dagger. You want to introduce Anvil into it just for improving your build time for generating Dagger factories. How do you go about doing that? So this is what you would specify. You would remove capped. You will remove Dagger annotation processor, and you're going to put this in there. You do need Dagger implementation dependency if you're, to specify the scopes if you have. So you would specify this in your build script, generate Dagger factories. And what you're going to do is that you're going to run the performance scenario without this change and with this change and compare the results. And you could set up a performance scenario to do that, like this, for example, for a particular module. So it doesn't have to be assembled a task. It could be a assembled task for a specific module. And you could graph basically like for each module, for example, what was it? What was the baseline? The baseline is without Anvil. What was the metrics for it? And you could take into account like what is the mean, or I would suggest taking the standard deviation for the before and after, and then you can look at whether it gives you a performance improvement in your project or not. So for me, this is a great library, Anvil, and Square wrote an article about this that you should check out. It's called Measure, Measure, Measure. So this summary, we looked at Gradle Profiler. So a really, really great tool that I would recommend and helped me a lot with optimizations and used a lot in the industry. And I want to say thank you for staying up late for this presentation. Not everyone works on Gradle. If you ever become the Gradle person wherever you work, hopefully this everything I discuss is helpful to you. So I want to say thank you to Shalom, to Android Worldwide for having me. Thank you.